let's look at G-GMD.A.1 worksheet, or activity 5A. It's a quick little activity, and so I'll be quick too. It's just basically relearning the constructions of the equilateral triangle, the square, and the regular hexagon, both just in general but also inscribed in a circle. And these are an earlier topic potentially for you as well. But I'll just kind of go over the basics, and then we can look at the specifics. But the idea is, if you want an equilateral triangle, you need 3 equal sides. And so if you make this the center of a circle and you construct its arc, we get something like this. And then if you go to this and make it the center and this the radius, you get this as well. And what happens is you get 3 equal sides. And by using a congruent radius, the same as the original given, you get 3 equal lengths, and therefore the equilateral. Now the cool thing is that the hexagon is the same construction, but done 6 times to some degree. So if you set this as your center and you do your arc and you do this one, you get this. So this is the first equilateral of the 6. Now if you use these 2 as your center points, and so if you had extended this arc and then extended this arc, you'd get another one, and so you'd get another location, and so on, and so on, and so on, and so on. And you create the hexagon by basically making 6 of the little equilaterals. It's a fun one. And then with the square, again, you would need to revisit the construction of a perpendicular. And if you swing your compass again at that same radius of this length to guarantee you get it here, you have this location. And then there are many ways to obtain the last one. You can do it by length of sides, you can do another perpendicular, and so on. But basically you obtain that last side, and then you have forced in the square. We'll look at them up close, but that's the basic idea of really it comes down to using congruent measurements, because these shapes are so locked into their form and size because of congruence. Let's demonstrate these 3 constructions quite quickly. And the idea of an equilateral is 3 equal sides. So here's one of the sides of our triangle. So if we create a circle with that same radius, we have many other possible lengths that will be exactly this length. And if we do it again from this side, we obtain another length from here to here. That is a radius that's the same as this. And because we use the same length, we get another radius that's the same. All 3 of those work hand in hand to bring about the equilateral. It's a cool little construction, isn't it? Now, in an identical manner, but a few more times, if we do that same construction, we obtain an equilateral again. Now, a hexagon is made up of 6 equilaterals. So let me just bring this down a little bit smaller. And then what I'm going to do is I'm going to use this as one of the sides of my equilaterals. So I'm going to make a circle from there too. And what you'll notice is I have created 2 more of my equilaterals, and I'm only halfway there. But do you see them? There they are. If I continue this process from here and then from here, I create the other key points. And so here we are here, and you can see the hexagon that's formed there, and there are 6 of those, and I can just shade that region here in, and you will see the hexagon. 6 equilateral triangles. Oops, I missed that point there. We'll go fix that. That should have been right here. So there is our hexagon. That's basically 6 equilaterals to form that. It's a very nice little construction. It's just repetition of this. And then finally, and again, I'm using tools here that you're not able to use. You're using a compass and a ruler to construct these, but this is the general idea. You would construct a perpendicular off of one of the endpoints here. And that, of course, gives you this location. Now you have two equal sides, and you have a perpendicular intersection here. Now you have some options. You can use some circle lengths to obtain this. You could do a perpendicular line here and a perpendicular line here. Most of you, I think, would pull out your compass and do a circle of that length from this point and a circle of that length from this point. And what that would guarantee is that this point is exactly equidistant to here as it is to here. Oops, I missed the point again, didn't I? Let's try that again, not being very careful. To here and then to here. And that region would be exactly our square. The reason that works so well is that the first intersection here was perpendicular, and that guarantees that as we go equidistant from these two locations, we would close out our square. Some nice constructions there, though.